In this question, we have to prove that P dot del A dot del 1 by R is equal to 3A dot R B dot R R5 minus A dot B upon R cube. We have to prove this. So del 1 by R is nothing but I dou by dou X 1 by R. It will give you sigma I minus 1 by R square, and dou R by dou X is X upon R. So finally what it gives you is 1 upon R cube sigma Ix. So it is R upon R cube. Alright. Now A dot del 1 by R is minus A dot R upon R cube. And now gradient of A dot R del 1 by R equals to I dou by dou X and minus of A dot R 1 upon R cube. I'll take minus sign outside. So this will give you I, and let me differentiate it one by one by using chain rule. This will give me A dot dou R by dou X 1 by R cube, and over here this will be plus A dot R, and d by dx of 1 by R cube is how much? Minus 3 by R4 and X upon R. So this will give you sigma I, sigma, if I have minus sign outside, this is A dot I 1 upon R cube minus 3 A dot R X upon R5. Sorry, I have to write I outside, R5. So finally what you get is sigma 3 A dot R upon R5 Xi minus 1 by R cube A dot I. So this will give you, if I take sigma out inside, this will be A dot R upon R5 sigma Xi, and 1 by R cube sigma A dot I. Alright, sigma A dot I. So tell me, what is this equal to? This is equal to R. And what is this equal to? This is equal to vector A. You remember what I told earlier in the beginning. This is vector A. So finally what you get is, in fact, this is equal to A dot del of 1 by R is nothing but equals to 3 A dot R upon R5. This is R vector. This is A upon R cube. This is A upon R cube. Alright. So B dot del A dot 1 by R is nothing but, this is A dot R B dot R upon R5 and A dot B upon R cube. Alright, this is how this can be done. Alright, so now I move on to the next question. Next question is, let's see this question. If A is a constant vector, prove that the curl of A cross R upon R cube equals to minus A upon R cube plus 3R by R5 A dot R. See, curl of A cross R upon R cube is basically by definition this is I cross dou by dou x A cross R upon R cube. Alright, so I differentiate it using chain rule. This will be 1 upon R cube, and dou by dx of A cross R will be nothing but A cross dou by dou x A cross R, and if I differentiate 1 by R cube, what I will get is minus 3 by R4 and dou R by dou x, which will be x by R. Alright, you can have two steps over here. So I have differentiated A cross R, keeping 1 by R cube constant, so 1 by R cube d by dx of A cross R will be A cross dou R by dou x, which will be I in fact. A cross R dou by dou x of 1 by R cube will be minus 3 by R4 x by R. I hope by this time you must have got how to do this. Alright, so this is I cross 1 by R cube A cross I, and this will be minus A cross R upon R5 x of x. Alright, so this will be equal to sigma 1 by R cube I cross A cross I, and this is scalar, so I can take here also xi also, I can take this x over here, so this will be sigma xi cross sigma xi cross A cross R upon R5. So finally what you get is sigma I cross IA minus I cross A I minus 3 R cross A cross R upon R5, and so this will be 1 by R cube also, 1 upon R cube. Alright, I hope you understand. So finally what we get is, this will be sigma, this will be A minus this is A, or I take sigma inside, so this will give you this will be given by this will be A, so A sigma 1, or 1 by R cube is there, 1 by R cube sigma A minus sigma I dot A I minus, this will be, I have taken sigma, okay, I have committed some mistake. See, I have already taken sigma over here, so I'll put it like this. Alright, I have already taken sigma in the second term, so I'll put it like this, minus sign. Alright, so this is 3 by R5, so R cross R is R square A minus R dot A R. Alright, so this will give you 1 by R cube, this will be 3A, and this will be A minus 3A by R5, or R square you can say, sorry, R cube, 3 R cube plus 3 R A dot R upon r cube. So finally what you get is, you get 3a dot r upon r cube minus a upon r. So this is r5, this is r5, so this is r5. So finally we get this. Finally we are able to prove this, 3a dot r upon r5 minus a upon r cubes. This is how this problem can be done. All right.